All right, so let me share the screen and let's start. All right, so let me know if you can see the screen. Okay, thanks. So just to recap a little bit, what we did last week is that we had created, like, for example, if we're talking about branch 1, right? So in branch 1, we can see that there were 3 switches connected to each other, and then there were 2 PCs connected to each of the switches, switch 1 and switch 2. So what we did last time or last week is let's say green color for VLAN 10. So what we did is that this computer here and this computer here, PC1 and PC3. So these two PC1 and PC3, these two actually belongs to VLAN 10, right? And the second part of this was PC2 and PC4. So this one and PC4, this one, they belong to VLAN 20. So we did a very simple configuration where we did 2 things. First was creating VLANs and associating the ports to the VLANs. And second part was the trunking between the switches, right? So, for example, if you want to have 2 VLANs, what we did was we, excuse me. So we created VLAN 10 and VLAN 20 on switch 1, switch 2, and switch 3. And then we configured this Ethernet 0/1 as part of VLAN 10, right? And Ethernet 0/0, sorry, as part of VLAN 10, and Ethernet 0/1 as part of VLAN 20. So the computers, although they are part of the VLANs, but they don't know. They are just simply sending the full frames, right? And same thing on switch 2, Ethernet 0/0 we configured into VLAN 20, and Ethernet 0/1 we configured into VLAN 10, and then Ethernet 0/1 we configured into VLAN 20. So that was creating VLANs and associating the ports which are going to the computers. And these ports which go to the computers or end devices, these are known as access ports, right? Now, if somebody asks you what is the difference between access port and a trunk port, so this is the trunk port between switches, right? So the access ports can be member of a single VLAN. They cannot be member of multiple VLANs. Either they can be member of VLAN 10, or you can change it to VLAN 20 or whatever VLAN you like, right? But it can never be more than 1 VLANs on an access port. On the other hand, the trunk port by default is a member of all VLANs, right? It allows all the VLANs to pass through the trunk. And we know we use a trunking protocol, IEEE 802.1q on the trunking ports. And the frames which are sent from one switch to another switch, that frame will be tagged with the VLAN ID inside the frame. So we also saw this, that a typical frame structure is you start with the destination MAC address, source MAC address, and then we have the type field data and FCS, right? But here we actually include a .1q, and then we have the type field, type/length field, then packet, and then the FCS, right? So your frame is same, but this is the new field we added where we have the VLAN information tagged there. So whenever switch 1 sends some frames from VLAN 10, it will tag them with the number 10. When it sends the frame for VLAN 20, it will tag them with the number 20. The only difference would be, excuse me, the only difference would be a special frame, or sorry, a special VLAN, which is never tagged. It is always untagged. Yeah, Trent. So I think audio looks good for everyone. Maybe you can check your headphone again. Try to disconnect and reconnect again and see if it works. Okay. All right. So do you guys remember which VLAN we do not tag? By tag simply means that if I'm receiving some frame from computer 1 in VLAN 10, and if the frame is going to the switch 3, for example, it will be tagged. You will put the number 10 here. There will be a .1q tag. But there is a special VLAN, right? And if the traffic comes into that VLAN, we never tag it. it goes untagged. So do you guys remember the name of that VLAN? Yeah, so I think Denise answered native VLAN. Very good. So the native VLAN, if you remember, what was the native VLAN? One of the VLANs you can configure as native VLAN. By default, it is VLAN 1, but you can configure any other VLAN as the native VLAN. And basically what happens is that any traffic coming into the native VLAN is always sent untagged. Means the frames you receive from the computers or the end devices, you send them as it is without adding the .1q tag. That is something we saw as well, right? Now, if you remember, we did something interesting in the last lab, and I'll tell you why did we do that, and kind of a load balancing scenario happens because of that. For end-to-end communication inside a VLAN, means inside a broadcast domain, you need two things. You need the VLAN should be created, and the interface should be part of the VLAN. And if you have multiple switches, more than one switches, then you must have trunking configured. So that's why we configured VLANs and we configured trunking. Once the trunking is configured, your circuit is complete. Your VLAN can travel end to end. For example, if computer 1 wants to send traffic to computer 3, which are into the same VLAN, it should be possible. Why? Because computer 1 will send the traffic to switch 1 on the port, which is part of VLAN 10. And because the switch has proper trunking configured, it will be able to send it to switch 2 or switch 3, and then they will be able to forward it to the correct destination, right? If it is within the same VLAN. So we did not see the inter-VLAN communication last week. If you want to enable communication between VLAN 10 and VLAN 20, we did not see that. What we saw is that within the VLAN, can we ping from one computer to another computer? If yes, then our practical was done for the last week, right? Yeah, so as Abdul said, in the assignment, we used the VLAN 100. So by default, it is VLAN 1, which is the native VLAN, but you can change it if you want. And what will be the example? Why would you want to change it? So let's say you have an organization where you are using a single VLAN. So you don't want to create multiple broadcast domains. Maybe it's a small branch or a small office, around 100 computers, and you want all of them into the same broadcast domain. But you do have 100 computers, so you do need more than one switches, right? So you let's say you put 2 or 3 switches, maybe 4 switches, connect them with the trunks, and connect all the computers. But you do not want to use VLAN 1, because generally what happens, VLAN 1 is used for the management traffic, for all the protocols we are talking about, .1q, CDP, VTP, CDP, all these protocols, DTP, these protocols use VLAN 1. That's the management VLAN, right? We cannot delete VLAN 1. So many companies, what they prefer is that even if they just want to use a single broadcast domain, they don't want to create, they don't want to use the default one, which is VLAN 1. So they say, okay, we will create one more, let's say VLAN 100, and all our computers will be into VLAN 100. So the management traffic or the protocol traffic can use VLAN 1, we will not touch it. But our company traffic, company data will travel through VLAN 100. So now, which kind of traffic will be more? Management traffic or company traffic? Of course, management traffic is very small, very minute packets like CDP control packets or STP or DTP. These are very small packets, so they will not take much bandwidth. But VLAN 100, which you have decided to use for your organization data, of course, your organization might send a lot of traffic. So it will use more bandwidth and it will send more frames. So it would be wise to actually change the default native VLAN to VLAN 100, so that most of your traffic will go untagged and you save that extra 4 bytes. And 4 bytes seems like nothing, but if you're sending million frames every now and then you can see million into 4 bytes. It creates a lot of extra overhead. So that is the basic idea behind native VLAN. Excuse me. So again, what is the basic idea? Create VLANs, associate the ports, configure trunking. Do 3 things and your practical is done. You will be able to ping within the VLAN, right? Not between the VLANs, but within the VLANs, you will be able to ping. Again, 3 things: create VLANs, associate the access ports to the VLANs, and finally configure trunking between switches. Now, let me tell you something very interesting. You can see that switch 1 has some ports connected to computers in VLAN 10 and VLAN 20. So I will create VLAN 10 and VLAN 20 on switch 1. Switch 2 also has ports into VLAN 10 and VLAN 20 because computers are connected. So I will create these 2 VLANs here. But why do I need to create VLAN 10 and VLAN 20 on switch 3 also? I don't see any computer connected there, right? So there is no use of VLAN 10 and 20 there. So why do I need to create VLAN 10 and 20 there? So Trent asks, does VLAN 1 need an IP address assignment for management traffic to pass, or is it all layer 2? So good question, Trent. It is all layer 2. You don't need any IP addresses on the switches. The only time you will configure an IP address on a VLAN is if you want to manage the switch, means if you want to access the CLI using the IP network, right? So if you don't have a console access and you want to get into the switch, then you will use that VLAN 1 IP address. But the protocols like STP, CDP, DTP, they are completely layered, right? Yeah, so I was asking, why do we need VLANs on switch 3 then? So you need to understand that, and this is a thumb rule you need to always remember, is that whenever you are creating a infrastructure, a switch infrastructure where there are multiple switches, make sure that all VLANs are created on all switches. Because there is a thumb rule, if a switch doesn't know about a VLAN, it will not allow the traffic to pass through for that VLAN. So think about this. Let's say you think, okay, switch 1 has 2 computers, one in VLAN 10, one in VLAN 20. So I will create VLANs on switch 1 and I will create VLANs on switch 2. But I don't need it on switch 3 because there is a trunking between switch 1 and switch 2. So you are right. Initially, you will not have any issues if you do not configure VLAN 10 and 20 on switch 3, and everything will be completely working fine. But the issue will start happening that if this trunk link goes down, this one, the trunk between switch 1 and switch 2, if this goes down, then of course the switch 1 will have to send the traffic via switch 3, right? And this is what will happen. Let's say switch 1 receives traffic from computer 1, which is in VLAN 10, right? So the switch 1 is going to send the frame to switch 3, but before sending the frame, it is going to tag the frame with number 10, right? The .1q tag, VLAN 10. So it will tag the frame with VLAN 10, and then it will send it to switch 3. But switch 3, you did not create VLAN 10 and 20. Remember, you thought, okay, let's not create it. Let's assume, let's say if you not created. Then what switch 3 will see that some frames are coming with the VLAN number 10, and I don't have VLAN 10 created on my my switch. So what I'm going to do? Drop the frame. It is going to create a black hole. It will drop all the traffic going from any VLAN, VLAN 10, VLAN 20, because you did not decide to create there, right? So I think someone said load balance and redundancy. So yeah, these are correct answers, especially redundancy part, because what happens is that you can see we have redundancy, means we have backup choices now. If the link between switch 1 and switch 2 goes down, the traffic will not be black holed by switch 3 if it is going via switch 3. So every switch must have the VLAN. Again, very simple rule to remember. If a switch doesn't have a VLAN, it doesn't let the traffic pass through for that VLAN. Simple as that, right? Again, I repeat, if a switch doesn't have a VLAN, means if you did not create a VLAN on that switch, it does not let the traffic pass through for that VLAN. That's why the best practice is to always create all VLANs on all switches within that particular LAN, like branch 1. So you don't need the same VLANs on branch 2. It's completely different. But in branch 1, make sure if you have 10 switches, all of them have VLAN 10 and 20 as well, because you never know the traffic might end up via which path or which route, right? Yeah, load balance is something which will I'll explain you when we come to the STP, spanning tree protocol, because right now the load balance will not work, because what happens is that spanning tree protocol will decide only one path, the best path for all VLANs, and it will just use the same link unless it goes down. Then it will start going through another path. But in spanning tree protocol, you will see we can decide that VLAN 10 traffic should always take the direct path, switch 1 to switch 2, but VLAN 20 traffic should go via switch 3, right? Another way to do it, which we did in the last VLAN, in the last lab, is to use the allowed VLAN concept, which we did, right? Allowed VLAN and specific VLANs are only allowed there. So, for example, let me quickly show you that, what I mean. So do you remember the last lab? I told you that between switch 1 and switch 2, allow only VLAN 1, 10, and 100, right? Between switch 1 and switch 3, allow only VLAN 1, 20, and 100. And between switch 2 and switch 3, allow only VLANs 10, 20, and 100. Now, this I told you to do so that you can do the practice for allowed VLAN things, but it's not a recommended way to do it because see, now what will happen? When the traffic comes from VLAN 10, and it needs to go to computer 3, which is also in VLAN 10. Now, switch 1 has two ways to go to computer 3. It can go directly to switch 2, or it can go via switch 3, right? But the problem is towards switch 3, we already said only these VLANs are allowed. VLAN 10 is not there. So switch 1 doesn't even have an option to send traffic over this trunk, right? So the only way to go to switch to go to VLAN 10 is via this way. So the VLAN 10 traffic will always take this path, always, right? On the other hand, if the traffic is coming from VLAN 20, the switch 1 can see that VLAN 20 cannot travel on the trunk which is going to switch 2, because VLAN 20 is not allowed on the switch, the trunk on the towards switch 2. So it will always take the path via switch 3. So yeah, this way you can do load balancing, right? All the traffic from computer 1 will always go via switch 2 if it is going to within VLAN 10. And all the traffic coming from VLAN 20 will always go via switch 3 because we did not even allow it on the other side. The issue with this configuration is that if now this link goes down, as I was telling you earlier, between switch 1 and switch 2, you can see that VLAN 10 is completely black holed because the only way now switch 1 has is via switch 3. And as you can see, the trunk between switch 1 and switch 3 do not allow VLAN 10. So that's not actually the best practice, right? The best practice would be to always allow all the VLANs which are in use on all the trunk ports so that you have options to use which one you want to use. And then you can use a spanning tree protocol, which we will see in the STB part, to load balance traffic between different VLANs. But the benefit will be that in that case, if one of the link goes down, you can still use the second part, which is the redundancy part, right? So then you will have load balancing as well as the redundancy there. So is this clear? So yeah, I think Simona asked that if I put a VLAN in a trunk, I remember that the switch configured the VLAN without the name. So what happens is that if you do not create the VLAN first, let's say I did not type the command VLAN 10, VLAN 20 to create them with the names. And if I try to use them somewhere in the trunk port or in the access port, switch port access VLAN 10, where I did not create VLAN 10, then the switch will think, oh, you want to use VLAN 10, so it will create it for you. And if it creates it for you, it uses the default naming structure, which is VLAN 0000 as 30 and then the VLAN number, right? That's why it happens. So is this clear? All right, perfect. So here actually I wanted to tell you something more. So this is something we already learned in the last session, and everything is very clear now, I hope. And if not, then feel free to ask me anytime. Don't worry. But here is something very interesting I want to tell you so that you have a little bit deeper understanding of how the networking works inside a switching environment in the branch side. So as you can see here is that we have 4 computers, and just for the sake of this example, I have used the MAC addresses I have used the MAC addresses A, B, C, D, right? My English is going a little bit haywire. So I have used 4 MAC addresses A, B, C, D. So computer 1 has MAC address A, computer 2 has MAC address B, and so on, right? Now, what happens is, if you remember the frame structure, okay, you don't need to remember, it's here. In the frame, you need to put the destination MAC address, that where you are going. And source MAC address is your own MAC address, so you always know that, right? Computer doesn't know about .1Q. So when the computer creates the frame, it doesn't put the tag. It is the switch which will put the tag. But here is my question. How do we know about the destination MAC address? Because the computers, they don't have the database of all the other MAC addresses, right? So when I told you, excuse me, when I told you that the computer 1, if it tries to go to computer 3, it will use the destination MAC address C here, right? In this DM field, which is correct. But how does computer 1 know that what is the MAC address of computer 3? So to understand this, we need to understand a protocol which is called Address Resolution Protocol, ARP. This is the protocol which helps computers to find out the MAC addresses or layer 2 addresses of the other computers on the same LAN, right? On the same broadcast domain. If you try to find the MAC address of something from another broadcast domain, another VLAN, another network, it's not possible, right? Because the ARP uses something which we all like or don't like, broadcast, right? It uses broadcast concept to find out the MAC address of the destination. Let me give you an example. So let me take this computer 1 here, just for the clarity. This is computer 1. We know that this computer is in VLAN 10. And the MAC address is A. And let's say, for sake of this example, IP address of computer 1 is 10.0.0.1. Right? And then we have connected computer 3, PC 3, to switch 2. Excuse me. Again, it is in VLAN 10. The MAC address is C. And let's say the IP address is 10.0.0.2. Because same VLAN has to have the same subnet or same network, right? There has to be a tight integration between VLAN and subnets. All right. Now, let's say you go to computer 1. Let's say this is PC 1. And you type the command ping 10.0.0.2. And you press enter. So you gave the IP address to the computer, right? That where you are going. So computer is very happy. It is saying, okay, I need two things to create a packet. I need source IP and destination IP, right? So source IP, I always know it's my IP 10.0.0.1. Destination IP you provided me. So thank you very much. I have all the information to create the packet. This part here. Packet is created. But now I need to encapsulate this packet into a frame. So I create the frame, right? And the frame, if you remember again, we don't need to remember, it's here. We can see that the first field is called destination MAC address. Second field is called source MAC address, and blah, blah, blah. We don't care the remaining packet and everything. So the PC1 say, okay, I need to create a frame to send to this computer. My source MAC address is A. I know that. But what is the destination MAC address? I don't know that, right? So how do I find the destination MAC address? I only know one thing about destination. Its IP address, that it is 10.0.0.2 somewhere, but I don't know what is the MAC address of 10.0.0.2. So that's where what computer 1 does, that it halts this operation, means it says, okay, you wait here. I am still not, I don't have complete information. Just wait here. Let me initiate a new process, which is called ARP, and I'm going to send an ARP request. And this request will be a broadcast. And you remember, broadcast goes everywhere in the broadcast domain. Right, so it will go everywhere within the VLAN. Broadcast doesn't mean it will go to all VLANs. That's the very literal definition of broadcast domain, right? It is the scope of your broadcast. So VLAN is your scope of the broadcast, right? So you create an ARP request, and what is the content of ARP request? The ARP request says simply, who is 10.0.0.2? Right? Who is 10.0.0.2? It is asking who is 10.0.0.2. Basically, what is the MAC address of 10.0.0.2? I don't have that information. And then you send this packet or this frame as a broadcast. And what do I mean by that? As a broadcast means that a destination MAC address will be a broadcast address, because this is also a frame, right? ARP request. And if you see this, let me show you here, the ARP request frame. So ARP request frame will also look something like this. We have the destination MAC address. Then we have source MAC address. Source MAC address will be A, and then the inside packet will be the ARP information, right? But again, we will have the same problem, right? We don't know the destination MAC address where we are going. That's the whole objective. We want to know the destination MAC address. That's why the destination MAC address will be all F. And if you remember from last week, I told you that all F means broadcast. So basically, you are asking switch to send it everywhere within the VLAN, within the broadcast domain. So now the frame, the ARP frame, or basically ARP request, is created, and then you send it to the switch. When switch receives it, let me change the color for this one. So let's use the black. So the computer 1 sends an ARP broadcast to switch 1. When switch 1 receives the frame and it sees the destination is broadcast, it sends it to all other ports in the VLAN 10. Again, it has to be within the VLAN. It cannot cross VLANs. So it will say, okay, I will send it to all other ports in VLAN 10. Now on switch 1, we don't have any other port in VLAN 10. Then what happens? So what happens is that every switch, when it receives a broadcast, it sends it to every other port into the VLAN and to the trunk ports where the VLAN is allowed. Let me repeat. When a switch receives a broadcast frame within a VLAN, it sends it to all other ports inside that VLAN and on the trunk ports where the VLAN is allowed. By default, all VLANs are allowed, right? So that's what switch 1 will do. It is going to send it to all other ports in VLAN 10. Switch 1 doesn't have any other port in VLAN 10. and then it will just send it to all the trunk ports. But as you remember in our practical, we did not allow VLAN 10 on this trunk, right? 120 and 100 only allowed. So switch 1 will not send it here to switch 3. It will only send it to switch 2 because the VLAN 10 is allowed there. So when switch 2 receives frame, and by the way, this is a very interesting part. When switch 1 is sending the broadcast to switch 2, this ARP broadcast, it is going to tag it with number 10. Because switch 1 wants to tell switch 2 that although it is a broadcast, make sure it goes everywhere inside VLAN 10, because I received it from VLAN 10, right? I don't want you to send it to VLAN 20, VLAN 100, and VLAN 1000, whatever you created. So the switch 1 will tag the frame with number 10. It's the broadcast frame, this one, and send it to switch 2. When switch 2 receives this frame, it sees, oh, you are going everywhere, but everywhere in which VLAN? Let me see the tag. So the tag says number 10. So, okay, I will send you on all the ports which are part of VLAN 10 and the trunk port. Remember, broadcast always goes on trunk port also. So switch 2 will send it to this port because this port belongs to VLAN 10, right? And it is going to send it to the trunk port because we do allow VLAN 10 on this trunk port. So switch 3 will receive it. Switch 3 will do the same thing. It will see, do I have a port into VLAN 10? No. But do I have any other trunk port where VLAN 10 is allowed, except the trunk port where I received the frame? No. So that's the end of it. I will stop it here. I will drop it, right? Remember, you do not send it back on the same trunk where you received it. Otherwise, it will keep on going forever, right? We don't want that. Now, when, and the story is not finished yet, right? It's just the interval. So right now. So the switch 2 sends the ARP broadcast to correctly to computer 3. Now, computer 3 receives a frame. Excuse me. Computer 3 receives the frame and it sees that the destination MAC address is all F. So it says, okay, it is sent to everyone. Let me remove the frame and extract the packet. What does the packet say? And it's an ARP packet, right? Address resolution protocol packet. What is the content of the ARP packet? This one here. Who is 10002? This is the content of the packet. So computer 3 will say, why? This is me. Yeah, I am 10002. So you are asking for me. Let me reply and I will send you something called an ARP reply. Right? So I will send you an ARP reply. And what is the ARP reply? From PC3 or computer 3, the ARP reply will go and the ARP reply will say, I am 10002 and my MAC address is C. This is the information we were looking for, right? Now this frame, the ARP reply, this is not a broadcast because we already know that the ARP request was coming from this MAC address, right? MAC address A. So now I can create an ARP reply going from me and destination is MAC address A. So that frame goes back to MAC address A, which is here. It goes back to computer 1. Computer 1 extract the frame, finds out the content which says my MAC address is C. It say, okay, now I have this information here, which I was waiting for the original packet. Remember, you pinged 10002 many years ago. So now the response is going to be there. So now the computer 1 say, okay, hang on, I'm pinging 10002. I'm on my mission. So I recently found out the MAC address of PC3 is C or 10002 is C. Now I will put it here, MAC address C. Now I have the complete frame and I will send it. And then it completes your pinging. Ta-da! So you see, seems like a huge process, but it happens very fast. And that's why you notice that when you ping it first time, the first packet is always dropped. Remember you ping 10003, it shows you 1 dot and then exclamation marks 4 times. It says 80% success rate. The first one is dropped because the ping times out because of this whole process of finding out the MAC address. But computer 1 is not stupid. The moment it finds out that, okay, 10002 is MAC address C, it actually puts it into something called an ARP table. ARP table, right? And it says, okay, 10002 is MAC address C. So next time if you ping again, this time I will just refer to this table, or it is actually called ARP cache. So ARP cache memory, and then I will use this information for faster ping. So second time it will be 100% success rate. right? It creates a record table. Exactly. So is this clear? How does the complete pinging works, or not just pinging? It could be any traffic within the VLAN from one computer to another computer. Is this part clear? Let me know. Or if you have any questions. Perfect. Okay, thank you. So now let me actually clear this to explain you what happens if you want to enable communication between VLANs. So inside the VLAN, now we are clear what happens. But between different VLANs, what do we need to do and how does it work, right? So that's why you can see the topic name is Inter-VLAN routing, right? Inter-VLAN routing means we want to enable communication between different VLANs. Okay, so basically you can go through this again, ready, and see that if you understood properly or not. What we are doing is that we want to go from one computer to another computer, right? And to go from any PC to another PC, you need two information: the destination IP address, the layer 3 information, and destination MAC address, which is the layer 2 address. IP address you provide when you type ping 10.0.0.2, you are telling the computer go here. So it already knows where to go on layer 3. So packet can be created, but it doesn't know what is the physical address of any of the computers. So it uses a protocol called ARP. And this ARP protocol is used to just send a broadcast. Broadcast means to everyone in my VLAN asking, hey, who is 10.0.0.2? For example, if we were in a physical classroom currently, and I don't know who is Brady, whose name is Brady. So I will say, hey, who is Brady here? So it's like a broadcast. And then you will say, hey, I am Brady, right? So you are replying. So that's ARP request, ARP reply. I will know, okay, this man is Brady, and I will always refer to him as Brady. So it's not any mistakes, or I don't talk to someone else with this name. Same thing with computers. They want to know the physical address. They use ARP broadcast, asking, hey, who is this? It goes everywhere in the VLAN. And of course, if that computer exists somewhere in the VLAN, it will reply back with the MAC address. And that's all you needed, right? You needed IP address provided by the user. You needed MAC address provided by the ARP. So does it make sense? Ready? Let me know. Perfect. Thanks. All right. So now, great. So now let's talk about the inter-VLAN routing. What do I mean here? So let me actually copy this also. This same diagram again. Inter-VLAN routing is between VLANs, right? So internal routing is not the correct word. Inter-VLAN routing, that will be the correct word, right? So between the VLANs. Intra-VLAN will be inside the VLAN, but inter-VLAN is between different VLANs, right? Perfect. So now what we want to do is, if you remember from our last example, and let's keep it simple for the conceptual part. Let's say computer 1 and computer 3 have the IP address 10.0.0.1 and 10.0.0.2, right? And computer 2 and computer 4, they are a part of the VLAN 20. So let's change the color. And let's say they have IP address 20.0.0.1 and 20.0.0.2, just different networks, right? So this is the basic idea, right? These are the bifurcations. This is VLAN 10 and this is VLAN 10. Sorry, this is VLAN 20 and this is VLAN 20. And the other two, 1 and 3 are VLAN 10. So now you want to enable communication between them. So remember, you are trying to enable communication between different broadcast domains or different VLANs. So for that, you need a routing device. You need a layer 3 device. So there are two solutions for this. One would be to use a multi-layer switch. That means where the switch is also capable of layer 3. But let's say, for the sake of this practical, let's say our switches are purely layer 2 switches. They don't have capability of layer 3, right? So the switches cannot help you enabling communication between VLANs. They will need the help of a layer 3 device, this router. And this router will actually enable communication between these two networks. And how does router do that? So what happens is, what happens in inter-VLAN routing is that you take the physical interface of the router, because it is connecting to both networks, right? So do you remember how many broadcast domains the router creates per interface? You can answer in the chat. router 1 interface equal to how many broadcast domains? Awesome. Look at that. All of you got it correct. And that is why it was the most important topic, the broadcast domain part. Now it will become very easy to understand. You can see there is a problem here. The problem is that we are connecting router 1 single interface to 2 VLANs, right? How many VLANs we have? 2 VLANs. VLAN is a broadcast domain. So how many broadcast domains we have? 2 broadcast domains. So it doesn't look right? Because we have 2 broadcast domains connecting to a single interface of the router. So, and do you remember that the computers, they always need a gateway IP address. A gateway IP address is nothing but your router IP address into the same network as the computer to get out of the network. So we have 2 networks here, network 10 and network 20. So which network am I going to configure on this Ethernet 0/0 of router 1 to configure it as the gateway? I cannot configure 2 IP addresses on the interface, right? I can configure 2 IP addresses with a secondary feature, but definitely I cannot configure 2 subnets on the same broadcast domain. So router 1 will say, my interface is creating 1 broadcast domain. That means I will only accept 1 network. 1 broadcast domain is 1 LAN, right? I will not accept 2 networks here. So I can configure an IP address in 10 network, let's say 10.0.0.254. And that will become the gateway for computers in VLAN 10. But then VLAN 20 computers will have no gateway and they will not be able to get out of the network, right? You need a gateway to get out of the network. If I decide to put network 20 on router 1 Ethernet 00, let's say 20.0.0.254 or some IP address, right? Then the computers from VLAN 20 will be able to go out of the network, but computers from VLAN 10 will not have any gateway. So it's not working out. It doesn't work. It doesn't make sense. We have a single physical interface on the router, which is a single broadcast domain, but we have multiple virtual broadcast domains on the switching side, multiple VLANs. So you know what router says as a solution? Router says, okay, so the switches are creating virtual broadcast domains, virtual LAN, VLAN, right? So let me go ahead and also create virtual broadcast domains. My single interface means 1 broadcast domain, but I can use something called sub-interfaces. The sub-interface means just a logical division, partition of an interface, physical interface, and every sub-interface is a broadcast domain. Just like every VLAN is a broadcast domain. So what I can do is this Ethernet 0/0, I can divide this into 2 parts. Ethernet 0/0 dot, we have to use a dot, and then some number, how many you want. So you can create 4 billion partitions of the same interface, as many as you like. So you can use any number here like Ethernet 0/0.1 and then Ethernet 0/0.2. How many broadcast domain you want? You can keep on going. .3, .4, .5000, .500,000, as many as you want. But the thing is that every sub interface, this way you create, is a complete interface. Just like every subnet is a complete network, every interface, sub interface is a complete interface, means you can configure IP address here, and this IP address can be different from this IP address. Because just like 2 interfaces of the router, 2 interfaces means 2 broadcast domains, you can configure different networks. As a matter of fact, you have to configure different networks because different broadcast domains. Now, every sub interface is a broadcast domain. So you are creating 2 sub interfaces, you will have to use different networks here. So then I can decide, okay, on Ethernet 0/0.1, I can configure IP address from VLAN 10. Let's say 10.0.0 something, let's say 10.0.0.100. And configure this IP as the gateway on the computer side. Same thing on Ethernet 0/0.2, I can configure 20.0.0.100. And this can be the gateway IP address for computers in VLAN 20. So just like the switches created multiple virtual broadcast domains, VLANs, the router can create multiple virtual broadcast domains on the same interface by dividing that interface into sub-interfaces, Ethernet 0/0 something. And generally what happens is that we keep it same as the VLAN ID. So like Ethernet 0/0.10 will be better because it is connecting to VLAN 10, and Ethernet 0/0.20 is better because it is connecting to VLAN 20. Do you need to keep it same as VLAN number? No, it could be any number, but it becomes easier, right? When you look at it later, and it doesn't confuse you much. You can see, okay, 0/0.10 is VLAN 10, .20 is VLAN 20. Easier to remember. But there is absolutely no requirement for that. You can use whatever you like. But remember, every sub-interface is a broadcast domain. But let me ask you this question. Excuse me. So router 1 created 2 broadcast domains now. Now, how many broadcast domains do you see? Because we created 2 sub-interfaces. So from router perspective, now we have 2 broadcast domains. And from the switching side, we have 2 VLANs active. So we have 2 broadcast domains there also. But the big question is, how does router 1 know that which sub-interface link to which VLAN, right? Because of course, there is VLAN 10 and VLAN 20. So how does it know which sub-interface link to which VLAN? You cannot say, oh, there is IP address. VLAN 10 is using the network 10, but that's a layer 3 information. We are talking about layer 2. Router 1 needs to know what VLAN, broadcast domain, which is a layer 2 concept. So that's why when you create sub-interface, you cannot configure IP address directly. You will have to first tell the router that this sub-interface is going to be used for VLAN 10. And this sub-interface is going to be used for VLAN 20. Then you can configure the IP address. Without that, it will not allow you to configure IP address. So once you put this information into the sub-interface that, hey, sub-interface Ethernet 0/0.10 belongs to VLAN 10, and this is the IP address. Ethernet 0/0.20 belongs to VLAN 20, and this is the IP address. Your work is done. And now you can just go to computers and tell them to go to these addresses as their gateway for VLAN 10 and VLAN 20. And you will be able to ping between VLANs also, right? So let me show you what will be the configuration of router 1 in this case, right? So it is called router on a stick. So this feature which we are enabling, which we are using, that a single router, a single port, physical port going to switching side, and we are creating multiple sub interfaces for every VLAN we have. This is called router on a stick because it looks like we are on a stick here, right? We are just connecting one single link from router 1, and it is enabling communication between all different VLANs by creating sub interfaces. So it's called router on a stick. The topic name is Inter-VLAN routing. So you achieve Inter-VLAN routing by using router on a stick, right? So if you see this keyword or if you see this keyword, don't get confused. They are the same thing if you are using a router, right? Now, we know that router 1 has Ethernet 0/0, which is going toward the switches. So what do we need to configure here? So we go to router 1, we go to the enable config mode, and then we go under interface. And you know what? Let me use typing for this, so it will become easier. Excuse me. Let's make it slightly bigger. Okay, so first of all, you go to the interface, Ethernet 0/0, right? Press enter. So this is the physical interface, which was the single broadcast domain. So we don't want to use it for IP addressing and VLANs because then it will be a single broadcast domain. We want to create sub interfaces. So all you do here is you just make sure that this is up. So you do no shutdown, exit, right? That's it. You enable the port. You get out the port now. You go back to the config mode, and then you start creating sub interfaces. So how many sub interfaces do we need? We have 2 VLANs, so we need 2 sub interfaces: Ethernet 0/0.10 and Ethernet 0/0.20. So you first of all you type the command interface Ethernet 0/0, and instead of pressing enter, you type .10, and then you press enter. So the system will automatically know, okay, so you are trying to create logical partition of the physical interface to create more broadcast domains. Here now, if I try to type the IP address, it will give me an error. It will say, if you are creating a sub interface, you need to tell me this sub interface link to which VLAN. So the first command you need to do is encapsulation .1q and then the VLAN number. So let's say this one I want to use for VLAN 10. And this is what I was mentioning, that do I need to use the sub interface number same as the VLAN number? No, it's not required. You can use 500 here for sub interface. You have to use the correct VLAN number That is the important thing, right? So encapsulation.1q 10 means this subinterface will be linked to VLAN 10, right? Now, the second thing is you can configure IP address. So this will be the IP address into the same network as VLAN 10, which is network 10. So let's say 10.0.0 something. So let's say 100. So let's say I'm using /8. There you go. And you don't need to do no shutdown here because these are logical partitions. Physical interface is already no shutdown enabled. So all you need to do is just exit and that's it, right? And then you create the second subinterface .20, same command, encapsulation .1q, and this time it is for VLAN 20. And the IP address will be into the same network as VLAN 20. So let's say 20.0.0.100, right? And that's it. Exit. That's all. That's all you need to do on router 1. Simple. Just creating 2 broadcast domains. Can you create more broadcast domains? Yes. You remember we have VLAN 100 also. So right now there are no computers connected to VLAN 100. So we don't need to enable any routing or anything. But maybe in future you connect some computers in VLAN 100 and you want others to go to VLAN 100. Then you will have to create one more subinterface. Excuse me. With the command encapsulation.1q 100 for the VLAN 100. And you have to decide what network you want to use for VLAN 100 because every broadcast domain, different subnet, right? So easy, so simple, right? But remember, the router is expecting now .1q frames. What does it mean? It means that if I receive something on this subinterface or I receive something on this subinterface, actually I'm receiving it on the same interface, Ethernet 00. Physically, I'm receiving it on Ethernet 00, right? So how do I know if the incoming traffic is for first subinterface or second subinterface? So we must receive the frames with the tag, with the .1q tag. So if I receive a frame with the tag 10, VLAN 10, okay, it is coming for this subinterface. If I receive a frame from with the tag 20, it is coming for this subinterface, right? Yeah, it is happening in config T mode, Rizwan. That's correct. Gloria asking is why this IP. So remember, we have we are using the IP addresses here in this example. We are using network 10 for VLAN 10 and network 20 for VLAN 20, right? And you will have to use the same subnet because remember the gateway IP address means the router IP address in the same VLAN should be into the same subnet also. So same broadcast domain, same subnet. So if I'm using 10.0.0.1 on computer 1 and 10.0.0.2 on computer 3, which are in VLAN 10, and then the subinterface of router, which is in VLAN 10, should be also in the same network. So it could be 10.0.0.3 because 10.0.0.3 is free, 10.0.0.4, 10.0.0.5. I just decided to use 10.0.0.100 because I was just feeling like that, right? So any IP address which is available in that subnet, you have to use that. Now in our lab, if you remember, I told you that for VLAN 10, use the first subnet of 10.0/29, right? This is the question. First subnet is for VLAN 10. Now /29, if you remember, I told you it will be 0 to 7. That means for PC1, I can use 10.10.1. For PC3, I can use 10.10.10.2 because it is part of this. And then see, from 0 to 7, I cannot use 0 and 7. So I have the usable range 1 to 6. So you can see 1 and 2 I already used on computers. So on the router, the gateway, I have to use either 3 or 4 or 5 or 6. I have only 4 options there. And then again, you can decide which one you want to use there, right? That's not a rule. So if someone is configuring .1 on the gateway, that is just their choice. What you need to configure on the gateway is the IP address from the same subnet as the computers it is connected to, right? The VLAN it is connected to. It has to be same subnet, and of course it should not be the same IP address. Otherwise, there will be a conflict. It could be any other IP address from the same subnet. So you can decide. Many companies actually have a best practice to use the last IP address of the subnet, like in this case, if it is 1 to 6, then generally they will like to have 10.10.10.6 on the gateway, like this. But it is completely your choice. But once you do that, what I was saying that time is that now your router is expecting the frames with the tag. because it needs to know whether the frame is coming for VLAN 10 or it is coming from VLAN 20. Because both frames you see will come on the same physical interface, Ethernet 0/0. Here we can see that when the frames are coming from VLAN 10, they are coming on the same physical interface, Ethernet 00. Frames coming from VLAN 20 will also come on the same interface, Ethernet 00. So how do we differentiate between them? So we need to receive the frame with the .1q tag, with the number 10 or number 20. So let me ask you this question. What kind of port is this Ethernet 1/0 on switch 3? Did we configure this as a trunk port in the last lab? The port switch 3 Ethernet 1/0 toward the router. So the answer is no, right? We did not configure it as the trunk port. And if the router 1 is expecting all the frames with the tag, with the .1q tag, you know that the switch only puts the tag, or switch only adds the tag on the trunk ports. It doesn't add the tag on any other ports, access ports or normal ports. So if you do not configure this switch side port as a trunk port, the switch 3 will not tag the frames with any VLAN ID, and then it will fail. Then the router 1 will have absolutely no idea which VLAN traffic is coming from, and your enable communication between VLANs will not work. So you have to make sure that apart from this, on the router side, which is the sub interface creating and this, you also need to go on the switch side, the interface which is connecting to the router, configure it as a trunk. Absolutely important. So switch 3 Ethernet 1/0 must be a trunk, right? So let me go to switch 3. So let's say here, then I go to switch 3, and on switch 3 I will go to interface under the conf t mode. Under the conf t mode, interface Ethernet 1/0, and then we use the command switch port trunk encapsulation .1q and switch port mode trunk. Absolutely important. Without a trunk configuration toward the router, it will not tag any frames, right? And if it will not tag any frames, the router will have absolutely no idea how to enable communication between them. So again, if we talk about the high points, what do you need to do? In the last lab, we created the VLANs. We associated the ports to the VLAN. We added the member ports, like on switch 1, Ethernet 00, Ethernet 01. And then we configured trunking between the switches. At the end of that practical, we were able to ping between the computers inside the VLAN. So inside VLAN 10, I can ping. Inside VLAN 20, I can ping. But between VLAN 10 and 20, there was no communication because there was no layer 3 device. So today we have to add router 1, or we have to configure router 1 Ethernet 0/0 with 2 sub interfaces with proper IP addressing and encapsulation, this part. And then we have to make sure that on the switch side, the trunking is properly configured. And what is the last thing of this practical? On PCs or end devices, configure the gateway IP address. Very important, because remember, the computers do not have the gateway IP information, that who is the gateway by default. They only know their own IP address. So they need to know that, okay, I am 10.0.0.1, but my gateway is 10.0.0.100. And why do I need the gateway IP? So that if anybody tries to go to another subnet, another network, then I will not try to send an ARP broadcast, because I know it will never reach to another broadcast domain. I will directly send the request to the gateway. So if you go to computer 1 and if you try to ping 10.0.0.2, same network, then it will use the ARP broadcast, which I mentioned you earlier, which I explained you earlier, and it will find out the MAC address and the whole thing, right? But if you go to computer 1 and try to ping 20.0.0.1, immediately computer 1 will see that, okay, the destination IP address is not in my subnet. So absolutely, there is no way I can reach there just by broadcasting. Broadcasting is not supported between subnets. So you know what? Computer 1 will not even bother to send an ARP broadcast, because it knows it can never find the MAC address of computer 2 directly. So instead, it will send that packet to the gateway. And for that, it needs to know the gateway IP address, right? Where is the gateway? 10.0.0.100, 20.0.0.100. So that's why the last thing is, on PCs, configure the gateway IP address. Absolutely important information, right? So having said that, let's go to our lab. What I'm going to do is I will show you the lab, and this is what I have done in the router on a stick or inter-VLAN routing lab, is that I have given you again the lab with the blank configuration. So you have to go ahead and do the same thing again. Configure the trunking between the switches and create the VLANs, and then also associate the interfaces toward the PCs to the VLAN and configure the IP addresses on the PC. So this part is same as the last lab. And the reason I gave you the same thing is just so that you practice more and make sure that you come to the right conclusion that we can ping from one PC to another PC in the same VLAN. Once we are there, then comes the router on a stick part, where we'll configure according to this requirement, right? So let me go ahead and start configuring these things. So first of all, configure the host name. So let's go to the lab. Let me quickly open these devices. So switch 1, switch 2, and switch 3. And finally, router 1, right? Ethernet 00 towards switch 3. Now, in the lab, you will see that you have a requirement to enable communication between VLAN 30 and 40 also. But it will be the exactly same thing again, or on router 2, Ethernet 0/1, the port which is going toward switches, right? Okay, Glory, there is a setting we can change in the PuTTY where you can say that receive the correct IP address. So I'll show you after the lab. So it's a very normal issue. We can fix it. No worries. All right. So let me show you in this part. So first of all, let's go to the lab again. So configure the host name and then configure these 3 VLANs, right? On switch 1, switch 2, switch 3. VLAN 10, 20, and 100, IT, HR, and corporate. So it's the same thing we did last time. So before that, let me see if the PC, because they are actually routers, so they do take some time. So let me just initiate the booting. Okay, so this is switch 1. Enable, configure terminal, or conf T, host name switch 1. And then we know that VLAN 10, name IT, VLAN 20, not 230. VLAN 20, name HR, and VLAN 100, name corporate. Right? That's it. Yeah, so if you do a copy run start, then what happens is that you will find the configuration is already there from the earlier lab. So if you want that, if you want to build on that, it's good. But I would suggest you initially to always wipe it back so that you can always practice everything again. Initially, the practice is very important, right? So you can see into the lab, the very first thing is that open the lab, and then on the left-hand menu, go to the more actions and wipe all nodes. If you do a wipe all nodes, your configuration will be back to the default configuration. So you can do this if you want to practice from 0. Yeah, so you don't even need to do write erase. You just have to do the wipe all nodes, and then it will take care of everything, right? No worries there. Okay, so let me show you one more thing here. I created 3 VLANs, and if I do a do show history, it might show you something like this. So it can be very easy to copy it from here. And if you, because you have to create the same VLANs, right? On switch 1, switch 2, switch 3. Don't worry, we will see the VTP practical in the later weeks, and we can actually replicate this information. But right now I have to configure it. So what I can do is I can just copy it from here like this. And here I made a mistake, like VLAN 230. I don't want to do it again and again. So let me just paste it here and remove this no VLAN 30 and VLAN 30. So this is what we need, right? On all the switches. So let me copy that. And let's go to switch 2. Host name switch 2. 3 VLANs, right? And then switch 3. Host name switch 3. And there you go, right? 10, 20, and 100. VLAN 30 and 100 have the same identical name corporate. Or maybe there is already a VLAN 30 here from my before configuration. Let me see. Oh yeah, okay. So let me just remove that. No VLAN 30 and no VLAN 100. And let's create VLAN 100 again. VLAN 100, name corporate, exit. Okay, so show VLAN brief, 10, 20, and 100. Perfect. So we have the first part done. Yes, Glody. So you're asking that, so do you suggest that even though we have configured up to the IP address part, we should wipe all the configuration and start all over? Yes, because as you can see that the lab requires you to wipe everything in this lab. And the reason is that we want to practice creating VLANs and trunking and all these things again. So it becomes quite natural to us, or it becomes easier to remember all of these things, right? So yeah, I would suggest you to do that. Thanks. So, okay, let's see the next part. Switch 4, switch 5, I'm skipping because it's the same thing you repeat. So you can try this. Okay, configure trunking between switch 1 and switch 2. This is something we already know. And you know what? This time I'm going to show you that if you configure this, it can show into the interface, show interface trunk. And if the link goes down between switch 1 and switch 2, you will have some blockage. There will be no communication because of this allowed VLAN thing we are doing. So it's not recommended, but here it's good because we want to practice this command, right? Okay, so we need manual trunking, VLAN 100 as the native VLAN, and 110 and 100 should be allowed only between switch 1 and switch 2. So switch 1 and switch 2 is Ethernet 02 and 03. So we go to switch 1. Interface range Ethernet 0/2, that's 3. So this will create a range. And switch port trunk encapsulation .1Q. First of all, select the protocol. Then manual trunking is switch port mode trunk. We don't use switch port mode dynamic for manual trunking. And then switch port trunk allowed VLANs. The VLANs we want to allow are 1, 10, and 100, right? Allowed VLANs, sorry, not VLANs. 1, 10, and 100. And finally, switch port trunk native VLAN should be 100, right? Again, it's the same thing on switch 2. So let me just see if I can check the history, do show history. And I can just copy this information from here, right? Yeah. So remember that the port should be same. Like in this case, it happens to be same. Like switch 1 side, it is Ethernet 02 and 03. And switch 2 side also Ethernet 02, 03. So I can literally just copy and paste it from switch 1 to switch 2. Perfect. That's done. What is the next part? Between switch 1 and switch 3, use dynamic trunking first of all. And dynamic means we are using negotiation, dynamic trunking protocol, right? DTP negotiation. So one should be the negotiator, another one should be accepting the negotiation. Switch 1 in this case is the desirable, means that should be the negotiator. And switch 2 is auto, means it should be ready to accept the negotiation. So everything else is same except that the VLANs that we allow are 120 and 100. By the way, there's a typo here, should be switch 3, right? Because it is between switch 1 and switch 3, not switch 1 and switch 2. So let me fix that in the PDF also. I'll send you guys new PDF if you want. All right, so let me just go ahead and configure this between switch 1 and switch 3. So switch 1 side, it is Ethernet 1/0 and 1/1. So we go to switch 1. Exit from this interface. Interface range Ethernet 1/0-1. And then we can use the command switch port trunk encapsulation .1Q. Switch port mode dynamic desirable, right? This is what is making it the active negotiator. And then switch port trunk allowed VLANs should be 120 and 100, not 110 and 100. And switch port trunk native VLAN should be 100. About switch 3 side, it should be Ethernet 0/0 and 0/1. So on switch 3, interface range Ethernet Ethernet 0/0/1. Switch port trunk encapsulation .1Q. Switch port mode dynamic auto. So this should be the one who should accept the negotiation. And then switch port trunk allowed VLAN 120, 100. And switch port trunk native VLAN is 100. So you see it's keep on giving me the message native VLAN mismatch. Until we fix it, it will keep on showing. So that's done. Okay, so I have two questions here. Let's answer them first. So Enrico is asking, what is the difference between native VLAN and normal VLAN? So first of all, welcome Enrico to the class. Native VLAN and normal VLAN, the difference here is that you always tag the frames with your VLAN ID when you are sending it from one port to another port over a trunk, right? So when the traffic is going over the trunk, the protocol .1 queue, which is actually the IEEE 802.1 queue, it is going to tag the frame with the VLAN number. So by default, the switch will tag all the frames which are going over the trunk with the VLAN number. If the frame is from VLAN 10, it will tag number 10. If the VLAN is from, if the frame is from VLAN 20, it will tag it with number 20, except for the native VLAN. Native VLAN traffic is always untagged, and the default native VLAN is VLAN 1. So if the VLAN 1 traffic is going from one switch to another switch, the frame will not have any tagging information. There will be no tag, right? And the other switch will understand that it is part of the VLAN 1. How? Because it will see, okay, a frame is coming without a tag, it must be part of native VLAN, because the only untagged frames accepted are from the native VLAN, right? So then it accepts that. In this case, we change it to VLAN 100, the native VLAN. So the VLAN 100 traffic will be always untagged, right? All right. So Simona is asking if port 2 and 3 are not in port channel, there will be a loop or not. So the answer to that question is no, Simona, there will be no loop. And thanks to our very old friend, STP, Spanning Tree Protocol. What happens is that if you have multiple ports connecting switches, STP will kick in and will block one of these ports, and it will not use that port for communication. Only one of the port will be used, right? So there will be no looping here. But of course, that means we are only going to use only one of the link out of two. So we are not utilizing the complete potential of the bandwidth. And that's why Ether channel is a good idea, which we will see into the next sessions. All right, perfect. So let's go back to the practical where we were between switch 1 and switch 3, I think. Let's do between switch 2 and switch 3 now. Same thing. We need DTP between switch 2 and switch 3. Switch 2 should be the negotiator, desirable. Switch 3 should be the auto. And the rest of the things are same, except the allowed VLANs are 10, 20, and 100, right? So let's go ahead and do that between switch 2 and switch 3. Switch 2 side, it is Ethernet 1/0 and 1/1. So let's go to switch 2. Interface range Ethernet 1/0 -1. So switch port, trunk, encapsulation, .1 queue, switch port, mode, dynamic, desirable. So this should be the active negotiator. And then switch port, trunk, allowed VLAN should be 10, 20, and 100, right? Finally, switch port, trunk, native VLAN should be 100. And on the switch 3 side, it should be interface range Ethernet 0/2 and 0/3 towards switch 2, right? So Ethernet 0/2-3. And same thing, switch port, trunk, encapsulation, .1 queue, switch port mode, dynamic auto, switch port, trunk, allowed VLAN should be 10, 20, and 100. And switch port, trunk, native VLAN 100. I'm going a little bit fast because it's the same thing we did last week also. And it's the same thing we already did between switch 2 and switch 1 and switch 3 as well. But okay, all done. Trunking is done. So what we have done yet, we have created the VLANs and we have configured the trunking. So what is missing here now? Even if you want to go within the VLAN, if you want to have communication, you remember I told you 3 things you need for communication. So VLANs are created, trunking is there. What is missing? So Glory answered associating the port. Exactly, that's correct answer. So always remember 3 things and just see if you have done all 3. So I created the VLANs, I configured trunking, associating the ports is still remaining, and I think that's the next part here. You can see that configure switch 1, switch 2, switch 4, switch 5 is also will be same, but we will concentrate on switch 1, switch 2 as access ports going to PCs in the correct VLAN as per diagram, right? So as per diagram, The ports of switch 1 are Ethernet 00 and 01, which are going to VLAN 10 and VLAN 20. Same thing for switch 2. Ethernet 00 is VLAN 10, 01 is VLAN 20. So let's go ahead and configure them, associating the ports. So on switch 1, interface Ethernet 0/0 going toward PC1, which is in VLAN 10. So switch port mode access. First of all, it's an access port. Why do we need to configure it as access port? Because access ports are allowed to be only member of a single VLAN, right? We need to make sure that make sure that that happens, right? And second thing is we want to make it the part of VLAN 10, right? So switch port access VLAN 10. And same thing for interface Ethernet 0/1, switch port mode access, and switch port access VLAN 20. Now, if I show VLAN brief, we have the VLAN 10 and 20, IT and HR, and the correct ports are member of these VLANs. Let's do the same thing on switch 2. Interface Ethernet 00, switch port mode access, switch port access VLAN 10, and interface E01, switch port mode access, and switch port access VLAN 20, right? Let's see, show VLAN brief. Yeah, all good. So all three things are done. First of all, we did the association of the VLANs. First of all, we did the creation of the VLAN. After creating VLANs, we configure trunking and now associating the ports. So our part is done. The only thing remaining now is that the PCs should have some IP addresses so that we can check if they can ping or not. So remember, for every VLAN, you need to use a subnet or a network. One VLAN should have a different network. Another VLAN should have a different network. So that part is also same into the lab, just like last week. PCs in VLAN 10 should use the first subnet of 10.10.10/29, right? First subnet. So this is something we already saw, that first subnet will be 0 to 7 from 10.10.10 network. So let's go ahead and do that on PC1 and PC3. So PC1, enable configure terminal. And here you can see into the question lab file, that on the PC, this is the structure you need to follow. No IP routing, then interface E00 and the IP address that you want with the no shutdown. Very important, right? So first of all, let me do a host name, PC1, no IP routing, interface Ethernet 00, IP address 10.10.10.1, and subnet mask should be 248, right? /29 is 248. No shutdown. And another PC in VLAN 10 is PC3. So that should be 10.10.10.2, for example. So go to PC3 and configure terminal. Host name is PC3. No IP routing because we are using it as a computer. Interface Ethernet 0/0. IP address should be 10.10.10.2. Second IP from that subnet, with the first subnet 0 to 7, right? 248. No shutdown. Exit. PC3 is done. Second part is that PCs in VLAN 20 should use the third subnet of 10.10.10.0 network. So as you can see here, the first subnet is 0 to 7, right? The second subnet will be 8 to 15. The third subnet will be 16 to 23. 16 to 23. Now I cannot use 16, nor I can use 23 because network ID and broadcast ID, or subnet ID and broadcast ID. So the usable range here is 17 to 22, right? So the usable range for VLAN 10 was 1 to 6. And here we have the usable range 17 to 22. So 17 and 18 I can use on PC2 and PC4, part of the VLAN 20. So let's go ahead and do that. PC2 should be 17 and PC4 should be 18. So enable configuration terminal, host name PC2, no IP routing, interface Ethernet 0/0. IP address should be 10.10.10.17. Let me show you if I type 16, what happens. Remember, 16 is the network ID or subnet ID, right? If you are using this subnet mask. So you can see that when I try to type this, it says bad mask /29 for this address. because this address is a start of the network. It's a network ID. It will not allow you to do that. So we have to use something between 16 to 23. So 17 will be fine, right? No shutdown. And PC4 should be 10, 10, 10, 18, right? So let's go to PC4. Host name is PC4. No IP routing. Interface Ethernet 0/0. IP address 10, 10, 10, 18, right? With the subnet mask 248. No shutdown. Did I no shutdown on PC2? Yeah, okay. So that's it. That's done. So you can see that after this point, after I configured VLANs, after I created VLANs, after I configured trunking, then I associated the ports to VLAN 10 and VLAN 20 and configured the IP addresses according to the VLAN, right? Now I should be able to ping inside the VLAN. So you can see, make sure you can ping between PCs in the same VLAN. So PC1 is 10, 10, 10, 1 and PC3 is 10, 10, 10, 2. They should be able to ping. So let's go ahead and check that. So if I go to PC1 and if I try to ping 10, 10, 10, 2, you know what's happening in the background? The moment you type ping 10, 10, 10, 2, PC1 says, I don't know what is the MAC address of 10, 10, 10, 2. So it actually sends an ARP broadcast and say, hey, who is 10, 10, 10, 2? And because it's a broadcast within VLAN 10, the switch 1 will send it to switch 2, switch 2 will send it to PC3, and PC3 will say, yeah, I am actually 10, 10, 10, 2. So it will reply with the ARP reply, proper MAC address of PC3, and it will come back to PC1. It will find out the MAC address, and then it will create the frame and ping. That's why you see that the first ping fails first time, because it times out before we can receive the ARP reply and create the frame. And then you get success rate 80%. But once you do that, you can see here, show IP ARP. When you type the command show IP ARP, it shows you, first of all, if the aging is showing you dash, means it's my local IP address. So this is my IP address, 10, 10, 10, 1. It will never age, right? But 10, 10, 10, 2, I found out, received it using the ARP, and this is the MAC address I received, whatever it is, right? It's a 12 hex numbers. And now if I ping, I already have this in my cache. You can see 100% success rate. Same thing you can check between PC2 and PC4. Let's try to ping the PC4. And one last thing quickly before we go to the main practical part is that, you remember I told you here is that we are only allowing VLAN 1, 10, and 100 here, and we are allowing 1, 20, and 100 here, right? Between these two trunks, this trunk and this trunk. So if I go ahead and shut down this link right now, same like if cable is disconnected or there is a problem between switch 1 and switch 2, you will see that the switch 1 have only one trunk now via switch 3. And on that trunk, we are not allowing VLAN 10. So the ping between 10.0.0.1 and 10.0.0.2 will stop. It will stop working. The ping between 20 or the other, sorry, we are using 10, 10, 10. So the ping between 10, 10, 10, 17 and 18 will still work because the traffic coming from VLAN 20 is still allowed. We can see 20 is here. And here also we have 10, 20 and 100 between switch 2 and switch 3. So 20 is still allowed. So then the traffic can go like this, right? But for VLAN 10, there is a black hole now if I shut down this link. Let me show you that. Let's go to this link, switch 1 to switch 2, Ethernet 02 and 03. Let's shut down this link. Same as if there is a link failure. So on switch 1, I go to the configuration terminal, interface range Ethernet 0/2-3. Shut down, right? Shut it down. And you don't need to shut down both sides, because once I shut down it, automatically the other side will say that it's not usable anymore. Now let's go to PC1 and try to ping the 10, 10, 10, 2 again, which is the PC3. You can see that now it's not working, because what's happening is that the traffic is going to switch 1 and switch 1 has no way to go to switch 2 now, and it cannot go to switch 3 because the allowed VLAN is only 1, 20 and 100. So VLAN 10 is not allowed. But PC2 should still be able to ping PC4. Voila, we can still ping it, right? So that completes our first part. And now you can see that the second part of the lab is where we do the router on a stick. So let's take a small break, 5 minutes. And after coming back, we will see how to configure router on a stick in this part, right? So see you guys in 4 or 5 minutes. Right, guys, I'm back. Okay, so can you guys hear me? Okay, thanks for confirmation. All right, so yeah, Abdul, okay, I'll talk to you after the class, then we will check it out, right? Thanks guys for confirmation. Let me share the screen again and then we resume. All right, so now what is happening is that we have our intra-VLAN communication going on, means we can ping between PCs inside a VLAN. Let me unshut the port which is between switch 1 and switch 2 so that we go back to the default configuration again. So interface range Ethernet 0/2-3, no shutdown, enable it again, right? So right now what's happening, I can ping from PC1 to PC3, I can ping from PC2 to PC4, but between them I cannot ping. So like from PC1, if I try to ping the PC2, which is in another VLAN, PC2 is 10.10.10.17, right? So you can see it's a different subnet and there is absolutely no communication right now. So what we need to do is we need to enable communication between them. So for that, we will do the next part of the lab, which is the router on a stick or inter-VLAN routing. So configure router on a stick on R1 with the following parameters. So configure switch 3 Ethernet 1/0 as a trunk port. Use the manual .1 trunking. You remember why do we need to do that? As I mentioned you that when you configure router on a stick or inter-VLAN routing, the router is expecting the traffic coming with the .1 queue tag. And it will receive the .1 queue tag only if the switch side is a trunk port. If the switch side is not a trunk port, it will send the frame without any tagging, and then the router will not know which VLAN it belongs to, which sub interface or broadcast domain it belongs to. So let's go to switch 3 and switch 3 Ethernet 1/0, which is going toward the router. Let's configure this port as the trunk port. So that part is very simple. We already know how to do it. Switch 3, enable configuration terminal, interface Ethernet 1/0, and switch port trunk encapsulation .1 queue, switch port mode trunk. That's it, right? 2 commands done. So switch 3 side configuration is done. Now the second part is configure the sub interfaces of Ethernet 0/0 on router 1 for VLAN 10 and VLAN 20, right? So we have to create sub interfaces because every sub interface is a broadcast domain, as I mentioned earlier. What IP address should I use there? So it is saying configure the last available IP address from the assigned subnet to that particular VLAN. So if I create a sub interface for VLAN 10, I should use the IP address, the last IP address of the subnet for the gateway IP, right? Same thing for VLAN 20. So you can see here that the range for VLAN 10 is 1 to 6. These are the IP addresses we have, right? So 10.10.10.1 and 10.10.10.2 are already on the PCs, PC1 and PC3. The last available IP address is 6. So the range is 0 to 7. Again, we cannot use 7, right? That's the broadcast domain. Broadcast ID. So we have to use .6. So 10.10.10.6 I can use for the VLAN 10 IP address, and 10.10.10.22 I can use for the VLAN 20 sub interface. So let's go ahead and create sub interface on the router with this. First of all, on Ethernet 00, which is going toward the switch, enable it, and then create the sub interface with the 00.10 command. So let's go to router 1. Excuse me. All right, so we are inside the router. Enable configuration terminal. Let's configure the host name R1. Okay, so we are in the router right now. Interface Ethernet 0/0, no shutdown. So first of all, the physical interface should be enabled. That's it. Nothing else we need to do on the physical interface. After this, we create the sub interfaces, right? So we configure interface Ethernet 0/0 dot and then some number. Now, as I mentioned earlier, that if you're creating it for VLAN 10, you can keep it 10. but that's not a requirement. You can use whatever the number you like, and it goes actually up to 4.2 billion. So you can go crazy with this, right? But generally people keep it same as the VLAN number, so it's easy to identify, right? So I'm going to use Ethernet 0/0.10 and press enter. You see that instead of showing you config dash if, which means interface, it is showing me the prompt now as a prompt. Config dash sub if means sub interface. So it's a sub interface. So when you configure sub interface, it's like a new broadcast domain. So you must tell the router which VLAN this broadcast domain is connected to, this sub interface. So I cannot configure IP address directly here. Let's say if I try to do that, let's say IP address 10.10.10.6, 255.255.255.248, and I press enter. See, it is saying that configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of the .1q, 802.1q, right? So it will not take the IP address until I type this command first, encapsulation.1q10, which simply is saying that it's a part of the VLAN 10. So let's go ahead and do that. So encapsulation.1q10. Now it knows, okay, I'm part of VLAN 10. That's it. And then IP address. Now it will take the IP address, the last available IP address of that particular subnet. Exit. Excuse me. And then interface Ethernet 0/0.20. So for this one, I will use the encapsulation.1q20. And the IP address that I will use is the last available IP address of the third subnet, 16 to 23. So the available IP address last one is 22, right? This one here. So let's go ahead and do that. 22. There you go. You don't need to do no shutdown here because these are logical subinterfaces of Ethernet 0/0, which is already configured with no shutdown. So they are already enabled. So let me show you how does it look like. You exit to the privilege mode and you can type the command show IP interface brief. So to see IP addresses and the status. So you can see that we have Ethernet 0/0, which is up, but there is no IP address. We don't want IP address on that one. We want to create two more. Broadcast domains, .10 and .20, which have the respective IP addresses, and that it's showing here. And they both are up. Very important. They should be up, right? All right. So our router side configuration is done. Our switch side configuration is done. The last thing is configure the PCs with the gateway IP address. So the computers need to know what is my gateway IP address. So all the computers in VLAN 10 should be configured with this IP as the gateway IP, 10.10.10.6. Because why this one? Because under this subinterface, I have used the command .1q VLAN 10, .1q10. And all the computers in VLAN 20 should be configured with this IP as their gateway IP. And I have given you the command that you need to use because we are not using actual computers. We are using routers as the computer. So you have to use a command on the config mode, IP default gateway, and then the IP address of the router sub interface, which belongs to that VLAN, right? So let's go ahead and do that on PC1 to PC4. So PC1, conft or configure terminal, IP default dash gateway will be 10.10.10.6. That's your gateway, right? And same thing will be on PC3 because PC3 is also part of VLAN 10. So I'll just copy it and configure on PC3 also. There you go. And 10.10.10.22 will be on PC2 and 4. So let's go to PC2. And 10.10.10.22 is the IP default gateway, right? IP default dash gateway 10.10.10.22. And same thing on PC4. So go to PC4. Enable conft and press IP default gateway 10.10.22. Now, these PCs have the gateway information. So the computers know where to go, where is the gateway. And the router, the gateway has proper sub-interfaces, which are the broadcast domains, and they have the proper IP address and VLAN assignment. And the switch 3 has trunking configured so that it can send the frames with the tag, so the router knows what to do with it, right? Yes, that's a good question. This one, we do not provide subnet mask when we are mentioning the gateway IP, because you provide subnet mask when you are configuring that IP somewhere. But here we are just mentioning the IP that, hey, this is the IP you need to go to. Just like when you ping, you don't provide the subnet mask, right? Ping 10.0.0.2, because you are just telling go to this IP. Whatever subnet mask is configured there, where it is actually residing, right? So now let's go to PCs, and they should be able to ping to each other, right? Excuse me. So earlier I showed you on PC1, I was trying to ping 10.10.10. Sorry, here I was trying to ping 10.10.10.17, which is another subnet, and it wasn't working. But now it should start working. So let's try this. Ping 10.10.10.17 and wait for the magic. Voila, you can see now we can reach to another network. Same thing, 10.10.10.18. You can see we can reach to 10.10.10.18. So this vice versa you can also do. You can go to PC4, for example. PC4 is 10.10.10.18. It should not be able to ping 10.10.10.1 and 2 without the Inter-VLAN routing, but now it should be able to ping because it has the information. So ping 10.10.10.1 and 2. There you go, right? All end-to-end communication is happening. So Trent is asking, later the wildcard subnet is used on a router. So wildcard mask is not a subnet mask. So we never use it for the subnet mask, but wildcard mask, yes, it will be used for other applications. You will see. For example, when we configure routing protocol like OSPF, there we use the wildcard mask, or when we configure access control list, we use wildcard mask. So you will see that we will use that thing. And it's a very, very amazing concept of wildcard mask. So when we come to that part, you will actually have fun with it. You will see that how does it actually work. Generally, it is called the stepbrother of the subnet mask because it looks like completely opposite of subnet mask, right? So we will see that part. All right. So now this is configuration part is done. Our lab is done. But what is happening in the background, that is very important to understand. So let me try to explain you that part. Excuse me. Let me clear this one and tell you what is happening in this particular example now. How the packet is going from end to end. That is something is very important to understand. So let me copy this again. The clean diagram. Okay, so now after we configured Inter-VLAN routing, let's change it to black, for example, to understand this. Okay, so after we configure Inter-VLAN routing, how is it working? What has changed and what is happening? So first thing you notice is that, for example, computers, they have gateway IP address now, that where to go. Now router 1 has E0/0.10 and E0/0.20, right? E0/0.10 has the IP address 10.10.10.6. And 0/0.20 has the IP address 10.10.10.18. Sorry, 22, right? 10.10.10.22. So that's the IP address. And we configured these as the gateway IP address on the computers. So what happens now is that when computer 1, you go to computer 1, right? PC1. And on PC1, you type the command ping. Let's say, for example, 10.10.10.17. Now we know 10.10.10.17 is computer 2, right? Computer 2, which is in VLAN 20. So we are trying to ping out of our subnet. So the very first thing that happens is that as soon as the PC sees that, okay, this IP address you are trying to reach is not in my subnet. So what does it do? So remember, the computer or any device always have two options. Should I send an ARP broadcast asking for the MAC address or should I not? So the answer is very easy. The PC finds out if the destination IP is in my subnet, then I will send an ARP broadcast asking who is this, and then I should receive the MAC address, which I need to create the frame, right? But if the IP address is not from my subnet, I don't send an ARP broadcast for this IP address, but I still send an ARP broadcast, and you will see that is very interesting. What happens? Let's go step by step. The moment you type 10.10.10.17, ping 10.10.10.17, the PC has all the information to create the packet, right? Because packet is what? Source IP, destination IP. You provided the destination IP. I already know my source IP. So packet can be created. So this will be the packet. Source IP address is 10.10.10.1, which is PC1. Destination IP address is 10.10.10.17, and the rest of the packet, right? So packet is created, no worry at all. But we know that we need to encapsulate this packet into a frame. So now the frame will have the destination MAC address and the source MAC address, right? What is the source MAC address? It's the PC1, MAC address is A. But what will be the destination MAC address here? Now remember, the destination MAC address cannot be from another subnet. So you will not go ahead and find out the MAC address of this IP address, because you know it is not part of your subnet. If it were part of your subnet, you would have sent a broadcast, find out the MAC address B and put it here, and then it will be done. But because the destination IP address is from a different subnet, you don't even bother to directly go there. Instead, where should you go? Anywhere, anytime you want to go out of your network, where should you go? What do you think? What is the answer? So you should not try to directly go to the other computer because it's not part of your subnet. So if something is not part of your network or subnet, where should you go? Absolutely. That's correct answer. You should go to the gateway, right? So you should try to go to the gateway. So actually you need to put the destination MAC address of your gateway so that this frame can reach to the gateway. And then the router or the gateway will take care of routing part. That computer doesn't care. So in case if you are going somewhere inside the network, you always use the destination MAC address of the destination computer by using our broadcast, finding out the MAC address. But if you are going to another subnet, you of course put that IP address into the packet. So the packet is showing you the actual destination, but the frame is only destined to the gateway. The frame has the lifespan of going to the gateway. That's it. That's its duty, right? But now we have another problem. Computer one say, okay, I want to go to the gateway. And the gateway IP address is, for VLAN 10, it is 10.10.10.6, right? But computer one doesn't know what is the MAC address of 10.10.10.6, which is the MAC address of this Ethernet 0/0, right? Again, you want to go anywhere, you need the MAC address. So yes, I want to go to the gateway, and thank you to the user. He has configured IP default gateway 10.10.10.6. So I know gateway is 10.10.10.6, but I don't want IP address. I want MAC address of the router so that I can send the frame to the gateway. So that's why you will send the ARP broadcast again. But because you are going out of the subnet, you will not ask who is 10.10.10.17. The question will change. So now the ARP broadcast will say who is 10.10.10.6, the gateway. So you are asking, where is my gateway? Who is 10.10.10.6? So the question changed, right? And then you send the broadcast, and you know the ARP broadcast means the destination MAC address is all F into the ARP frame. So you keep this frame aside, this one, because you don't have the destination MAC address of the gateway, and you create a new ARP frame, and the destination MAC address is all F, sending it to everyone, asking who is 10.10.10.6. So when this goes to switch 1, it's a broadcast frame. So switch 1 says, I will send it to every other port in VLAN 10 because I am receiving it in VLAN 10 and the trunk ports, right? So it will send it to the trunk ports. So let's say that on the trunk between switch 1 and switch 3, we are only allowing, if you remember, we are only allowing 120 and 100. So it cannot go on this one because the frame is coming from VLAN 10, but I will send it to switch 2 because I am allowing VLAN 1, 10 and 100 between them. And then switch 2 receives it. It's a broadcast in VLAN 10. So it sends it to the port which is connected to the VLAN 10. That means computer number 3. So the broadcast will go there also. And computer 3 will see a broadcast frame, open it and see the question, who is 10.10.10.6? Computer 3 will say, hey, I am not 10.10.10.6. So I will just ignore it. So it will ignore it. Okay. But then apart from the ports in VLAN 10, you also send it to all the trunk ports, right? Except the trunk port where you received it. So switch 2 will receive this frame, send it to the PC3 and to the switch 3. And you remember which VLANs we allow between switch 2 and switch 3? 10, 20 and 100. So the frame is coming from VLAN 10. The tag is number 10. So I will be able to send it over the trunk. So then it will go to switch 3. And when it reaches to switch 3, it will see that a frame is coming, a broadcast frame is coming in VLAN 10. I will send it all the ports which are part of VLAN 10 and to the trunk port, right? So again, switch 3 has no ports in VLAN 10, but it does have trunk ports, right? This trunk port doesn't allow VLAN 10, so I will not send it this side. But you remember we configured this one as a trunk also, Ethernet 1/0. And we did not configure any allowed VLAN command. So all VLANs are allowed. So we will send this ARP broadcast to router 1 also. So when computer 1 asked, who is 10.10.10.6? This is how that broadcast frame reached to the router 1 via switch 1 to switch 2, switch 2 to switch 3, and to router 1. It could have gone directly from switch 1 to switch 3 if we did not use that switch port trunk allowed VLAN command, where we deliberately said don't use VLAN 10, right? So this is how it reaches to router 1. Again, router 1 sees a frame is coming, destination MAC address is broadcast. It opens the frame. It's an ARP frame asking who is 10.10.10.6. And router 1 say, oh yeah, I am 10.10.10.6. So let me reply with the MAC address of my Ethernet 0/0. Every interface has a MAC address, right? So then you send an ARP reply, and the reply goes specifically to MAC address A. So it will again travel through this way, go to computer 1. And now computer 1 will get the MAC address of Ethernet 0/0. Let's say the MAC address is E, right, for the example. So then it receives by computer 1. Then it is going to put that MAC address here in destination MAC address E. And now the frame is complete. And then you will send the frame. Now see what will happen. Sorry. Just a bit, my MAC address, sorry, my mic is creating an issue. So can you guys hear me? Just let me know in the comment if you can still hear me. Oh, okay, thank you. Yeah, I just wanted to make sure we don't miss anything. So you say frame, once we have the frame here, once we create the frame, sorry, the inside of the frame, the packet is going to the 10.10.10.17. That's where we want to go. But the frame wants to go to the gateway. So now it will reach to the gateway, to the router 1 via the same thing, same concept, right? Sorry. So it will use the same path. It will go to the router 1, and router 1 will see, okay, now the frame is coming to me. So I can dismantle the frame, extract the packet. And when I extract the packet on router 1, I find out, oh, it wants to go to 10.10.10.17. Let me check my routing table. And the routing table says that 10.10.10 network 10.10.10.17 is part of this subnet, right? 10.10.10.22, same subnet. So that means I can send the frame out Ethernet 0/0.20. Now you can see that the frame is coming on Ethernet 0/0 and going out again Ethernet 0/0. So what has changed? How does it enable communication? Remember, when the frame was coming from computer 1, what was the tag from switch 1? What was the tag switch 1 will put if the frame is coming from computer 1? What do you think? What will be the tag? So I received this frame, this one, from computer 1, which is trying to go to MAC address E. I will send it to the other trunk ports. But what will be the tag, .1q tag I will put after the source MAC address in this frame on switch 1? What do you think? So the correct answer is 10. Yes, because you put the tag of the source. You received it on which interface? From computer 1 on Ethernet 0/0. So that port is in VLAN 10. So if I'm sending this frame out, the tag will be 10. So this frame here will become something like this. Destination MAC address is E, source MAC address is A, and then you have the number 10, and then the source IP, destination IP, the rest of the things. So the tag will be the tag of this one. So this is how it goes via VLAN 10 to the router 1. And that's why it reaches to the Ethernet 0/0.10, because router 1 receives the frame with the tag 10. But now router 1 sees, it removes the frame and finds out that you are trying to go to 10.10.10.17, which is the same subnet as Ethernet 0/0.20, right? So then it sees, oh, Ethernet 0/0.20. Let me see what is the configuration of 0/0.20. Encapsulation .1q 20. Okay, so I need to change the tag to 20. So that's where the magic is happening. The router is changing this frame to tag 20, because it says it has to go out the same interface, but this time the tag should be 20. And you know, the whole thing is happening again because router 1 says, okay, you are trying to go to 10, 10, 10, 17, which is connected on Ethernet 0, 0, 20. So let me send an ARP broadcast on VLAN 20 asking who is 10, 10, 10, 17. So this broadcast will go everywhere in VLAN 10, VLAN 20. And then it will go to computer 2 also. And computer 2 will reply back, hey, I am 10, 10, and 17. My MAC address is B. Remember, this ARP broadcast is going over Ethernet 0/0.20 because 10, 10, 10, 17, according to router 1 configuration, it's part of the same subnet as 10, 10, 10, 22. So that's how it finds out that the destination MAC address is B. Source MAC address is router 1 because router 1 is sending the frame now. The source MAC address is E. And then the packet will be same, this packet here. So the packet will be sent like this. Now, finally, it is going back, but with the different tag 20. So it will be going to the interface Ethernet 0/1 because that's where the MAC address B is connected. So that's how the inter-VLAN routing works, as you see. What it does is that it allows you to receive the frames from one tag on the router, and then the router sees the routing table that where is the destination IP address and change the tag according to the destination subnet or destination broadcast domain, right? Okay, so you didn't understand how did we change the tag? This one? Yeah, so when the frame is coming from computer 1, the tag is 10 and it goes to router 1. But what is the destination MAC address of that frame? We are sending the frame to the gateway, right? So the router 1 is going to delete the frame, means remove the frame and extract the packet. So that frame is a history now, this frame with the tag 10, because the destination was router 1, destination was gateway. So it has already reached the gateway. So this frame is history. You extract the packet on router 1 and find out that the packet wants to go to 10, 10, 10, 17, which is as the same subnet as Ethernet 0/0.20, the second subinterface. And what is the tag on that subinterface? What is the tag on Ethernet 0/0.20? The tag is 20, right? So now if router 1 sends the traffic back, it will use the tag 20. So that's how the tag changed, right? And now because it's VLAN 20, it will be allowed to go all the way to computer 2, which is part of the VLAN 20. So does it make, is it clear now how the tag is changed? All right, perfect. So that completes our practical, that completes our lab also. And we just made sure that we created the whole thing again. And by the way, guys, the requirement to create VLANs, trunking and associating port, you will see this into many labs because I want to make sure you practice this again and again. So as long as you see the labs where I'm asking you to wipe all nodes, please do that. So don't just build upon on the earlier ones. Don't worry. Later, when we come to the routing part, we will configure these things already, and then we will concentrate more on routing. But as long as switching is going on, we want to practice this one as many times as we can, right? All right. So that's the basic idea, right? And that completes our lab. So let me know if you have any questions. So let me do one thing. Let me go ahead and enable, let me unmute you guys so you can ask me questions if you have any questions or doubts about this one. Okay, so you can ask me into the chat, or you can also unmute yourself and let me know if you have any questions. Okay, so we have a few questions here. First of all, I think Enrico is asking, could be a case that aggregate port is not coming up. So I'm not exactly sure what are you referring to here, Enrico? Exactly, like which part? Meanwhile, let me see the next question. So Brady is asking, basically we are doing week 2 lab, combining it with the week every week. Yeah, that's right. So this is the strategy I have right now, is that switching, core of the switching is you should be comfortable with how to create VLANs, how to associate ports, how to configure trunking. These 3 things you should be able to do in your sleep, right? So that's why in every lab we will do in switching part, later like VTP, STP labs, you will have to configure it from scratch, starting from creating VLANs, associating ports and creating trunk. So I would request you to not cheat. Don't save your configuration. Always start from zero so that you have enough practice that it becomes very easy for you guys and to understand the concept, like, right? That is the one thing. Rizwan is asking, could you explain the naming interfaces? So by the way, the naming part, Rizwan, is not something we come up with. It's actually for the hardware we are using. So the Ethernet, you see E00, E actually stands for Ethernet, right? So Ethernet means we have 10 Mbps ports. So if you have devices with 100 Mbps capacity, you will see that the name is fast Ethernet, FA0/0, FA0/1. If you have routers with gigabit Ethernet capabilities, means 1000 Mbps, you will see the port names will be GI00, GI01, gigabit Ethernet. So this is something depends on which router you are using, which switch you are using, what are their capacities, right? So we don't come up with these numbers randomly. They are the ports that are available there, right? All right, so Emilian is asking, can you explain when you type the command no shutdown? So the no shutdown command is configured on the routers. So this is a good question. Let me actually share the screen again. So what happens is that by default, the switches, they have all their ports up. You don't need to unshut them. So let's say if I go to one of the switch, let's say switch 1, and if I type the command show IP interface brief, right? The command we use to see that whether port is up or down. So you can see that all the ports of a switch are by default up. They are always up. So we don't need to do no shutdown on the switches. But on the router side, every layer 3 device, by default, the ports are disabled. You have to enable them. So let's say I go to router 1, and here I type the command show IP interface brief to see the status of the interfaces. You see that Ethernet 00 and Ethernet 00.10 and 20, they are up because I did the no shutdown there. But what about the every other port that I have? You can see they are administratively down. So administratively down means the shutdown command is there by default. You have to no shutdown them if you want to use them, right? So on the layer 3 device like routers, or in our case, the PC are also routers. So you have to make sure you do the no shutdown on the interface before you can use it, right? So I hope this answered your question, Emilian. And okay, so the Glory is asking, could you show me the settings for super? But yeah, so I will show you in a minute, Emilian. And in the same case, you don't type that command. Yeah, so in the switches, we don't type it. In the routers, we have to type it for the interfaces. Very simple to remember, right? So make a saying show IP interface brief will show you interfaces. Yeah, that's right. So show IP interface brief is a very good command to see all the interfaces you have and which one is up, which one is down. So you can see and what is the IP address. So a lot of very useful information is there. On the switching side, there is another good command, just like show IP interface brief. There is a command show interface status. This is a layer 2 command, which shows you which port is part of which VLAN, which port is trunk, and all these things. So you can see it's very useful. In switches, Ethernet 00 is part of VLAN 10, 01 is part of VLAN 20, and these 4 ports are trunk ports going to switch 2 and switch 3, right? So very, very useful command. And the remaining ports, we did not do anything, so they are part of VLAN 1. So very useful command. All right, so any other question? Okay. So Rizwan is asking, at one end it's E00 and on the other end it's E01. So this is confusing. Okay, so basically what happens is that it's not required to use the same interface name both sides. It could be any interface. So what happens is that the addressing in Cisco starts with 0. So it's 0/0 is the first one, as you can see. And then you can see that 0/1, 0/2, 0/3. And after that, it starts with the second block. So 1/0, 1/1, 1/2, 1/3, right? Now, which one will connect to which one? That depends when you are creating the topology, right? So when I was creating this topology, let's say I click on node and I add the node here. Cisco IOL, let's say, and I'm adding some device here. Let's call it switch, and let's add two of them just to show you example. Let's say I have these two devices, right? So you can see that when I try to connect them, it is asking me on switch side, switch 22 and switch 23, right? So switch 22 side, which port do I want to use? So it's entirely up to me which one I want to use. Let's say Ethernet 02. Another side I want to use Ethernet 00 or maybe 0001. So you can start from the first one, but then if that is already connected somewhere, that's not available, you go to the second one and third one. So it's entirely basically up to you. How do you connect them, right? So let me delete this. So you can see that on switch 1, I use Ethernet 00 first to connect to PC2, 01 to PC, 00 to PC1, 01 to PC2. And then when it comes to connecting to switch 2, 00 and 01 are already used. So I have to use 02 and 03, right? And same thing between switch 1 and switch 3, because switch 3 doesn't have any computers, 00 and 01 were free. So I use them when connecting to switch 1. So it doesn't matter which one you use, as long as you know which one is connecting to which one and you configure the correct configuration on both sides, right? Perfect. All right. So let's see the question which I think Glory was asking regarding the naming. So yeah, basically, let me show you that I think it happens in the putty. So if you go to super putty, let me see if change setting. Yeah. So basically just click on any of the tab, like for example, you have multiple tabs here, right? Just click on any of the tab, right click and click on change settings. When you click on change settings, it actually open the putty settings, right? So putty setting, this is where that setting is to get the name into the tab instead of IP address. So make sure you select the default settings here. And then you go here and then you have to find that setting. So I'm also not exactly sure where it is. Let me see where that is. Should be in the Windows somewhere. Let me see where it is. It's somewhere it says that don't change the name of the tab or name of the session. Shift override applications, use of mouse, no compromise, no, not here. I don't exactly remember where, but it's somewhere here. Let me see. It is showing me for a specific one. Let me see. Let's not go here. Let's go to the default putty setting. So it's actually not the super putty, it's the putty which is creating this behavior. Super putty is just like a front end bringing the putty in, right? So let's just go to the putty. You open the putty wherever it is. You can also go to the super putty tools and options, and you can see where is the location of your putty.exe file, which you're using. So you can open that, and I think here also it says putty configuration. So you can open putty configuration. Let me see. Yeah, this is the default one. So appearance window. Push erase text, push reset to scroll back on display. Not this. Display scroll bar. Terminal should be the terminal one. Yeah. Let me see. Is it the session? No. That's very strange. Actually, this is somewhere here, which I'm forgetting where exactly is. It says that don't use the original method and change it. Yeah, okay. So you see, this is here. Under, you have to go to the main putty configuration, wherever it is. So what you can do is, from your super putty, you can go to the tools and putty configuration, right? Tools, putty configuration. And then you go to the terminal features, right? So terminal features. And here you see this option here, 1, 2, 3, 4, 5, 6. So the sixth option, disable remote controlled window title changing. You have to make sure this is unchecked. I think by default it is checked, or it is checked in your case. That's why it is just using the IP address. So just uncheck this. And what will happen is that the remote control means the EVNG will be able to change the title to whatever the device title name is. So make sure you disable that. You make sure it is unchecked when you're using disable remote control Windows title changing. So is it clear? You can try this and let me know if it works. It is initially unchecked. Okay, so maybe you can check it and save your configuration. What happens is that maybe it is not taking the configuration changes. If you go to putty configuration features, let's say you have selected here, and then you go to the session and default setting and save, and then go back and uncheck it, session, default setting, and save again. You can try this. That should work. Otherwise, if there's anything in the option of the super putty, let me see. GUI. I don't see anything here. Shortcuts advanced. Yeah, I don't see anything here. I think it should be the same thing. So you can try that. If it is still doesn't work, we can check it. Then we can have a session, and then I will try to see that why it's not showing up there, right? All right. So let me see another one. So Rizwan is asking, whilst doing installation, etc. for super putty, it says execute the file. Does that mean just to open that file, or do we have to do something else? Brief video for that installation would be extremely interesting. So yeah, super putty is execute the file. Yeah, you just have to install it, right? You have to just install it. It's a software that you need to install. And once it is installed, then you have to do the setting changes as I send into the Word file. So if you still have any issue with that, let me know and we can connect and fix those issues as well. No worries. And Gloria, let me know also if that works. Otherwise, we can connect later, right? So any other technical questions from today, or all good? So guys, if you have any other issues or any question, please feel free to send me a message anytime. By the way, one more thing I wanted to say, and I will send an email also regarding this, that we have the 8th session, I think, because we started on 5th of March. So I think the 8th session will go. So the 8th session will be on 23rd, right? And the 9th will be 30th. So I think either 8th or 9th, we have the switching part will be completed, and then the routing part will start. So in that time, we will take a 1 week break there. That means in 1 week, we will not have a class. We will have the later week when we start the routing. There are 2 reasons for this. One reason is that in that particular week, you should do all the labs again of the switching, just to make sure that you are completely okay. And of course, when you're doing them again, if you come up with some issues, I will still be available. Just that we don't have the sessions in that week. So that in that break time, you can do all the labs again to have a complete revision. Generally, what happens, we have seen in the classes that something is taught and then you go ahead and there are so many new concepts. Something old is completely down there, and then you start forgetting that. So we have to make sure that switching part is very clear. So you get the whole week free. After the 8th or 9th week, I will exactly check and send you an email regarding that, so that you can go through all the labs again. Let me know the questions on email or Facebook chat group. And after that, when we start routing, you will be completely fresh. That means, okay, everything is clear from up to the switching part. and then we start the important routing part, right? So yeah, for the exam, actually the topics that we are covering, and then at the end of this course, you will see that you will get the complete complete shelf of our videos of CCNA videos. So you can go through all the remaining videos also from our CCNA course after the live course, which are mostly theoretical. So all the things which are practical, we are covering in this course, but anything like theoretical OSI model, TCP/IP model, or anything like that is there into the videos. So you should go through that, and then you can actually ask me, and I can give you some practice questions to go through before you take the exam. So technically, you will not need any book, but if you do have a book like Cisco Press book or any other book, that will be fine also. You can actually go through that. No. So Abdul is asking, do we have to sit for CCNA or can we sit for CCNP test? So as far as the exam is concerned, you have to pass CCNA exam if you want to go for CCNP. It's technically entirely not true. You can directly go for CCNP and you can pass the exam, but it will not be valid or active unless you pass CCNA also. So you will have your certificate, but it will be in suspended state basically unless you pass CCNA also. So the only exam that doesn't need anything else is the CCI exam. Interestingly, you just need to take the qualification exam, which is the Encore exam, and you can directly go for CCI without doing CCNA or anything, and that will be valid. But for CCNP, you do need CCNA. So yeah, so Jeffrey is asking, will the recordings be left on during the duration of the 24 weeks, or will we have access to them after 24 weeks is over? So this is something I want to tell you all to all of you guys, is that the recordings that we are having, these Zoom session recordings, these will be available to you lifetime. So lifetime availability. So you can actually go through them as many number of times as you want. It will be available to you forever. And although it's a 24 weeks course, so my availability is only 24 weeks. But even if you have any questions later, like after 2 years and you suddenly have a technical question regarding CCNA and you shoot an email to me, I will be more than happy to answer you. So you can say lifetime support as well. No worries there. But I hope you don't need lifetime support. You will definitely get your CCNA soon and you will be on your path. You will be helping me in some cases in that case. Yeah, no worries. All right, guys. So I think that's it. If you have any other questions, you can always send me an email and we will talk there. So I think there's Enrico is asking, all the switches modules have the same configuration or there are some differences? So yeah, that's a good question, Enrico. So the switch module actually doesn't make any difference as long as the VLAN configuration or the basic configuration goes, like trunking and all. But there are minor changes. You will see that there will be some differences in a way that, for example, some switches do not even support ISL protocol. So we have two trunking protocols, .1q and ISL. And if both are supported, you must type the first command, which is switchport trunk encapsulation .1q, because you want to tell the switch, I want to use .1q. I don't want to use ISL. But there are some switches who do not even support ISL. They only support .1q. So they don't need that first command, switchport trunk encapsulation .1q, because the only option is .1q, right? So you can directly go switchport mode trunk or switchport mode dynamic desirable or auto, right? So like that. So depending on the models, yeah, there might be slight changes into the configuration, but the core concept will remain same. All right. So that's it for today. And if you have any other questions, please feel free to let me know on my email. I will be more than happy to answer you guys. Right. Bye-bye, everyone. Thank you, everyone. And Abdul, I will send you an email right after this. So let me know if you receive that email and we can talk from there. Right. Okay. Thank you.